Hello, so the video you're going to see is going to be about this, the Strahlenspurgerat, if I'm pronouncing that right, which I'm probably not, which is a type of ionisation chamber radiation detector that West Germany used for a while. I don't actually know how long these were in service. Now, I'm guessing by the name, where it says somewhere like that, 1963, that these are from the early 60s. I mean, obviously, it had to be from the early 60s if it said from 1963, but you know, I mean, I don't think it came out in the 50s. But you can't find much info on these online. I found a couple of manuals that were in German, and although they were meant to be translated, as in Google showed you a translated thing in the preview, as soon as you clicked them, it wouldn't let you translate them, which is quite frustrating. But this one has a stamp on it from 1986. So they must have stayed in service quite a long time. And I don't know if that was the last time this was in service and then they retired it or whatever, or if they kept it for longer. There's also a stamp saying 67 there. So, you know, who knows. But anyway, I don't want this video to come across as being Germanophobic. This is why I'm doing this bit now, later on, because I thought when I came to edit it, it's going to seem like I'm really having a go at the Germans on this, and I don't want to make it, you know, I want to explain that I'm not coming across as that. The problem is with this, and I'll try and do this, explain all this in the front of the video so you can see what goes wrong with it. It has the typical German problem of being, like, very clever ideas but a bit too over-engineered. Whereas there are, like, one or two bits of this which would have been really, really good if they kept it simple. Like, probably one of the best ionisation radiation detectors. The issue was that obviously they did the thing of, we need to add loads of features, cram as much in as possible, make it more complex, of course, more things to go wrong, and what you'll find out in the video is there's a couple of very fragile parts, and if they break, it causes massive problems. Remember, stuff like this was designed to be used like Geiger counters. If the Cold War went hot, nukes had gone off, and you were in a very bad situation. You did not want to, you know, rely on something that's going to break down. If you look at the US CDV 715, is it the 720? The 715 is just a plain ionisation chamber unit. The 720, if I'm remembering the number right, is the one that's basically, the 715 bit has a beta window at the bottom like this. So the 720 is probably the most direct comparison between this, but that's still very simple compared to this. Now what I'm going to suggest, and this is something I want to say before you watch the rest of the video, so if you skip through this, you know, you missed my warning, so bad luck to you, because people are asking me if I thought these were any good or not. They may be, right, if you buy one that's in working condition, whatever you do, do not open it. If you go through the checks, right, because I've had to take the check source out now, because you'll see why in the video it sort of breaks the thing. So let's say you do your check, so you go to B, then you go to C, and it does the circuit check, you know, saying it's at full power. Great, now we go to M, and it goes to the 0. The thing won't be displaying properly because you have to look at it this way up, which is another irritating thing with it. You can't have it on a shelf. You might be able to re-zero it on a shelf, but I don't think it really works. So it has to be held up like this. Another irritating thing with this is if you sort of shake it slightly, the needle jumps around quite a lot. I know other ionisation chamber units have that issue due to how ionisation chambers work, but I don't think I've ever seen videos of people moving CDV 715s around where the needle really goes like, woo, woo, you know, it only moves a little bit in comparison. So if let's say you're in Germany and you see one of these that you could buy second hand and you can, you know, you get a chance to have a quick look over it, I'd say if it appears to be working, so you do those two things and then you do the test that won't obviously work on this because I got the check source out. You go to the 5 Roentgen per hour setting, and what it's meant to do is when you have that on R, it's meant to zero at or you're meant to zero it manually at 3.5. Because what it's basically saying is the check source should read 3.5 Roentgen. Now, what I wanted to do in the video, which I'll explain as the video goes on, was I thought I was being clever and basically going, I'll open this up, it should be easy. I'll take out the check source, and I'll also show you what the Geiger, not Geiger, I can keep on calling that, but it's an ionisation chamber, not a Geiger counter. I thought what I'll do, I'll show you the check source. And then what I was going to do is I was going to measure the check source with other Geiger counters to actually see what the check source, you know, activity was, so I could zero this correctly. That turned out to be a very, very bad idea. The check source they put in this is carbon-14. Now, carbon-14 is really interesting because It's a beta emitter, but it's such a weak beta emitter, most Geiger counters can't even read it, or they'll give you a false low reading. It actually can be read properly by Geiger counters with alpha tubes on, like alpha micro windows. So my mini monitor is my only Geiger counter that actually reads it properly. This could actually read it properly because it's inside the ionisation chamber, which is part of the problem. So the big flaw in this, which you'll see in the video, is there's a couple of very fragile mechanical parts and bits that can jump, and bits that are really hard to reset to factory settings unless you took loads of detailed photos of where every bit was before you started messing with them. You know, I've never seen other units that have that problem. You know, it's very clear where bits are meant to go if you move them about. But this is, you know, very clockwork and German inside. They weren't meant to be making a fine watch, they were meant to be making something to survive a nuclear war and tell you how screwed you were in radiation readings. So again, it has lots of nice features. So for example, if you're on the radiation thing, it does the thing like the British Radiac survey meter, where when you flick through the Roentgen settings, it actually updates on that wheel there. That's a really nice feature. I wish lots of Geiger counters did that, because then rather than having to do the multiplication in your head, or am I on the times 10 scale, am I on the times 100, times 1000, or another weird multiplying factor, it literally shows you, so it's much faster, so you can get your reading and know, all that sort of stuff. So yeah, the point is, if you see one of these, it's in good condition, don't open it. It may very well work, just don't tinker with it, because the problem is it's very precisely engineered German stuff, which, it's not really fit for purpose, but it could be a good thing if it's in good condition, and you don't need to play around with it. And the thing is with carbon-14, because it's so low energy beta, this can read it fine, and it has a massively long half-life. So if it reads anywhere close to 3.5 Roentgen on here, you zero it to 3.5 Roentgen like the instruction says, and you leave it. You don't need to worry has the check source decayed, it won't have done, because of what's in there. So that's what I'm going to say about it. So I hope the video doesn't come across as Germanophobic, but I got quite frustrated with this because it was something that could have been really good, but it was the typical German over-engineering problem of making something that's really good and high quality, but then letting it down by having one or two design flaws or cheap parts, which kind of break the whole thing. Like some of the German heavy tanks of World War II had very weak engines in them, so it didn't matter how good the armour and the guns if they keep breaking down. It's that typical problem. So as much as I love some German engineering for how good it is in a sense, and finely crafted, it can often be let down. So there you go. As I said, I don't want to make it sound like I hate Germans in this video or anything like that. It's just to basically explain to you, my frustration in advance, so when you watch this video you don't think I'm being such a prick. So there you go, enjoy the video and hopefully you'll find it entertaining, I guess. Hello, so this turned up today. It is apparently a Strahlenspurgerat, and what that means is radiation detector. Now I don't think this is a Geiger counter, we can actually open it up and look at the insides in a minute when I've cleaned it. But this was the West German, or one of the West German radiation detection instruments for the Cold War. And it does a scale from 0.5 Roentgen per hour, so up to 500 milliroentgens, all the way up to 500 Roentgens per hour. At that point you're very dead. A very interesting thing of this is it has a built-in dosimeter, but it has 3 digits that keep rolling over, so as you're exposed to radiation it rolls over. Although I'm not sure if you can operate that and that at the same time. I think it might be one of those units you have to either select have it in dosimeter function or, like regular reading function, which is a bit annoying if that's the case, but still pretty advanced for the time. It's a pretty compact unit. It has a little carry strap there if you wanted to carry it by its own carry strap. Now if we look at the bottom, you can see there's actually a beta shield there, and I think how this works is basically it's an ionisation chamber, and then in the bottom you've got a sort of a thinner bit of it where it can actually beta can go through. So gamma rays and X-rays would penetrate the device into the ion chamber no matter where it is, but if you put it down on top of a radioactive sample that's heavily contaminated beta, it would give you a reading. So it takes one D-cell battery that goes in there. I loosened this up a bit earlier with a screwdriver to check there's a battery in there, so I can actually take that out thankfully without needing to get one handy, but I will get a screwdriver in a minute for disassembling it. So yeah, it's just one D-cell battery it takes, which is pretty good because a lot of Geigers are pretty intensive, and it means it doesn't use an obsolete battery format, which is always nice. So that's the device itself, and it would help if I keep it in frame, wouldn't it? So yeah, this particular one, it has a sticker on it somewhere I saw. There we go. So this particular one is from 1986, and I don't know if that means it was inspected in 1986 and they found it still worked and was okay, or if it was manufactured then, but there we go. So that's what it looks like on the top, and for any of my German viewers or anybody that speaks German, you'll be able to read that. Basically, a lot of the functions are done on it with a weird combination of switches, but I suppose that makes it more compact than having loads of switches. So for example, to do one thing, you might flick one switch to one position, do it in another, and then it will give you like one of the readouts. That's pretty interesting, because I've not seen many devices do stuff like that. With a lot of devices, as said, you normally end up having loads of switches on them, which clutters them up a lot, but that's actually pretty compact. So yeah, what we're going to do, I'll just quickly show you the case this came in actually. So this is the case of the Strahlenspurgerat, or whatever it's called. So as you can see, it's basically a nice cloth padded case, which obviously gives it a bit of insulation in case you drop it. In the bottom there is a flap. Now if I get this open, I have to obviously unpeg it. How this works is there's obviously a bit of metal in here, and that will block the beta radiation. So if you wanted to read gamma only, you'd have to have it in the carry case. But I mean, once you've got it all set up, there's no reason not to really have it in the carry case, because it's a nice, compact sort of canvas carry case. Then how it works, obviously, is you have it in there, and then you do this sort of drawstring up around it when it's in there to hold it in tight. And I assume it's got a manual in here behind this bit. So let me just try and get this manual out without bending it. Well, it's probably been bent from being in there for ages. So there's a bit of padding in the lid as well, that's kind of nice. And then, let's see if this will actually come out, because it's pretty firmly wedged in there. Let me try and turn this bit up like that. Tell you what, let's pull the padding out. It might give me a bit more room to move it out. Right, there we go. So I'm assuming this is an operator manual, or is it just a bit of card? No, it's just literally a bit of card. I thought, oh, there's going to be a manual in here, but there's not. So there's something here. I assume that's like a dog tag. I hope that's not a radioactive check source. If I'm holding it in my hand like that, I will check that in a moment. What else is in there? Nothing. There's two compartments, but there's nothing in either of them. So, yeah. Right, what we're going to do now is I'm going to clean the actual detector. So, what I've got is, I might as well show you this process as I do it. I'm going to clean it, then I'm going to open it and have a look at the inside, show you what's inside it. Hopefully try and get the camera at an angle, probably elevate it a bit more where it's a bit of a wider frame. And then we'll do it. I've tested it and it seems to work, but I need to calibrate it. Now, it's got a radioactive source supposedly inside it, which should be used for zeroing. However, the issue is that, obviously due to the age of the thing, the source might not be it might not be as strong as it once was. So if that's the case, what I'm going to have to do is, obviously when I take it apart, try and get probably my DP75 Geiger counter next to it, take a reading of what that gives me, and check it calibrates with the reading the actual device gives me. That way I can zero it properly. Because the actual check source in there is 3.5 Roentgen per hour of beta radiation. Not quite 3.6, so it's not great, not terrible, but yeah, a pretty bloody strong actual source, you know, for testing it with. So anyway, let's get on with the cleanup bit of the video. Okay, so to clean this, I'm going to use some silicone lubricant, which is what I use on gas masks, as it's generally, as it says, for lubricating metal, plastic, vinyl, rubber and wood, etc. So it's kind of like a polish, but generally it doesn't harm most substances. And I'm going to use a silicone impregnated cloth, which I use on a lot of things like this, or like gun barrels and things like that. So we'll open the cloth up, and then what I'm going to do is spray a bit of silicone lube onto the cloth, because obviously I don't want to get any of the liquid into any of like the sort of ports on there or whatever. So give that a shake so it comes out properly. There we go. And then let's give this a polish up. And hopefully it will look a lot nicer, newer and shinier by the time I'm done polishing it. Right, that's the top done. Looks quite a bit better. I'm probably just going to put a bit more on one of the corners of it. So I'll just do that there. But yeah, somebody asked me about one of these on one of the streams, and they said, you know, these turn up now and again in Germany, are they any good? And they thought they were a Geiger counter, that's what I thought initially. I'm pretty sure it's an ion chamber, but we'll find out for sure when we open it. And yeah, by the look of it, it does seem very good if you get one in working condition. But what we're going to do in a moment, obviously, as said, is just open the baby up. It's a lovely kind of Bakelite-y plastic looking case on there. Now I'm obviously on the side, I'm not so concerned about, you know, worrying about getting stuff in it. I'll be careful with the beta window as well though, but that should in theory be metal or something on there. Because generally how it works is because beta will penetrate obviously a lot more than alpha, but nowhere near as much as gamma. Most times the beta window on something is like a very thin piece of metal that it can penetrate through, or you know, like plasticky stuff or whatever. I hope you don't find this cleaning video too boring on polishing up a Milsep Geiger counter. And I'm sure because this is the internet, somewhere somebody gets off to people polishing, you know, radiation detecting equipment. Right, so I'll be careful now not to get any of the spray into the battery compartment, obviously, or the beta window. So let's do this. See if we can get that bit of plasticky crap off of there. And then I'm going to have to work out where the screw holes are to open this up. Actually, I can see the film underneath there for the beta window, so what I'm just going to do is very gently just do that, and then that should get any crap off of there, because you never know if there was any radioactive residue left on it, which you'd hope not, but you never know. So, right, there we go. I'm going to get my screwdriver set, and obviously the battery is out. Very important factor. I know this should apply to all electronics, but when you're working with radiation detecting equipment, a lot of them run at stupidly high voltages. The American CDV 700, I believe, is even like 900 something volts. I don't think they're very high in amps, but they're high in volts, so you could get a nasty shock from it. So obviously it makes sense to take the batteries out before you start opening them up with a screwdriver. Now there's two screws there, but I don't know if that completely disassembles it. What it also might have is screws under these feet, but I can't see any there. So I'm assuming it will probably be, yeah, an entire case where it lifts out on the lid. So right, let me get my screwdriver set, and then we will open this baby up and see what's inside. Right, hopefully I've guesstimated correctly the size of the screwdriver I need. So let's see, my hands are a bit shaky today. There we go, that's unscrewing nice and easy, so I think I got the right size. And the nice thing is these screws seem to be in good condition, because I'm sure some of you are pretty familiar, you'll sometimes buy old military equipment and the screws like rusted in and you can't move anything. Obviously AUS is off, so I've got it set to off. I don't know if AUS means off or if it means exit, because isn't Ausgang like the word for exit in German? But yeah, so there's at least 4 screws in this cover. I'd have thought there'd have been more, but let's have a look. Will it lift up now? That still moves. Right, how is this lid going to come off? Because I can't see any easy way of opening it. But you obviously can open it, because you need to if you need to service anything in it, change anything around. Right, I'm going to have to figure out if the straps need to be in some sort of weird... not the straps, sorry, the switches need to be in some sort of weird combination for it to open. Because with some of these devices, like, they're locked if you have the, you know, things in certain positions. But it also could just be that I need to lever the top off. So what I'm going to do very gently is with a small flat head. I'm going to be gentle because obviously if this starts doing something that's not meant to, that could be a problem. But with some of these old units, you'll find the lid has been stuck on for ages and then it won't want to move. But obviously I don't know if that is the case here. Now I wonder if this is on poppers, if we can take these off, because maybe there's some screws under there. Doesn't want to... right, let's get the strap off first. There we go. Right, that's that bit there. So if we push that, pull that, that's that one. I'll get both of these off just for convenience. I might not keep that on there because it'll be in the bag most of the time. Right, let's see if these come off via flathead screwdriver. So I don't want to obviously put too much force on anything, but these might just literally be metal clasps that don't do anything. But and of course it could still be that there's some sort of opening mechanism under these rubber feet, but I wouldn't think that would be the case. But just see if there's an easy way I can get one off without damaging it, to see I think there may be a screw in there. What I'm just going to do is get the small screwdriver, put that in there and see if it will turn. Let's try the next size up. I'm assuming it would be sort of a similar type of screw. See if I think that's turning. Is there anything coming? Hard to see. And that's if it's not some sort of specialised screw they've got in there. The thing is, though, I don't want to really damage anything. Let me just try one of the other ones in case that one's just stuck, like I was saying is often the case with these old bits of milsurp. I don't know if that's doing anything. Right, let me, I don't really want to do this, but because I'm going to need to calibrate it, I'm going to need to get inside it. So, let's see what happens if I push this washer like that. Right, the washer comes off, and then, it's an Allen key. Right, okay, I'm pretty sure that's an Allen key. So I'll get the washers off, at least they can go back on. And again, it might be one I don't even use the washers if it's in the bag all the time, but... So yeah, let's lever these off. Hopefully not damaging them, but with some of these, this one rubber's a bit rotten by the look of it. So yeah, I might just leave them off on all of them if it will sit properly in the bag without the rubber feet on. Could probably quite easily replace some of these. Yeah, this one's just puncturing, so there's that one. Yeah, still should be in usable condition. I wonder if it'd be easier to lever them off on the inside, probably not. There's that one again. I'm sort of having to puncture some of these because the screwdriver sort of just goes through the rubber so easily where it's got old. And it's almost like, I think this one's been glued on. Right, I'll probably bin that one. Right, let's just get these two off. What's going to be annoying is if I figure out afterwards there was some really easy release method for these. Yeah, they put glue on some of them, so yeah. You're probably not going to get these off if you've got one of these without ripping them. Right, there's that. Right, let me get my set of Allen keys, and now we'll get the bottom of this open. I might put the screws back in the top before doing that, because it could obviously be that those screws are for something else, and I don't want to have anything suddenly fall out if I pull the bottom off. That way. So, yeah. I'll redo the screws on the top off camera, I'll get my Allen key, and then we'll see what's inside. Right, so that did indeed need an Allen key, and now these are coming up. It looks like they're sort of a thumb screw type design with a washer, but obviously it's an Allen key type screw, not anything. So yeah, this will definitely be the things, because these are very big and long. Which obviously is what holds the lid of the case on, or, you know, this to the lid of the case, or whatever they attach to in the case for that matter. But the point is they're big, long, sturdy things, they're not going to, you know, fall out easily. Fall out easily, it's a radiation detector. What a shit joke. Right, let's lift this up and see. Will it open now? Or am I? Oh, there's still one there I've missed, that's why. As I say, or am I going to have to take those top screws out again and put back in? But we'll find out in a moment. There's a weird smell coming out of it now. It's not particularly unpleasant, it's just very strange. Right, so we will just come off now. Because there should be, in theory, nothing holding that together. Right, let me just retake those screws off again that I just literally put back on. Because I reckon that it's probably held on in two places. How they've designed that, I don't know, but yeah, I'm very interested in what the check source is in this. If it had a manual, it would probably tell you if it was strontium 90 or whatever, but it doesn't. Also, if this Geiger counter has got a stamp there that says 67, if it was designed in the 60s, when was the last check source put in it? Because obviously that makes a factor as well. Because stuff like strontium 90 has about a 30-year half-life. So, obviously, that's the issue with old Geiger counters. If you're using it as a check source, it's not going to necessarily work. Right. How is it going to come apart now? There we go. Right. That was a bit dramatic. So, dun 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 dun. Yeah, it's an ion chamber. It's not a... Right, that's very thin paper, so I have to be very careful with that. So yeah, it is not actually a... Oh, it's a very interesting check source. Look at that. So the check source, I'm going to have to be very careful with this because I don't know exactly what it is. I'll get the Geiger counter in a minute. The check source is actually on a steel beam, and it inserts it, by the look of it, into the side of there. That's fascinating. I've never seen a check source done like that.
But I'm assuming it has a second beta window there. Oh shit, electric current still on there. Yeah, but don't be an amateur and do it like me. But yeah, that's how I assume it works. That, see, the case is actually very simple. Or is that the check source there? What's that there then? There's something there. I doubt that would be the check source. Actually, that looks like some sort of grainy material, so maybe it is the check source. Who knows? Right, let me get my Geiger counter, like another one. This is actually an ion detector unit, not a Geiger counter. Difference being it has an actual ion chamber with a very thin piece of paper on. I should stop touching, because if I break that, it'll probably break the actual seal of the unit and it'll be useless, because obviously that's filled with ions, this chamber here. Well, not filled with ions, it's you know, filled with a gas of some sort. The difference between an ion chamber and a Geiger counter is that the Geiger counters, what's the word for it? Geiger counters have a Geiger-Müller tube, which is positively charged. These have an ion chamber. Pros and cons of each one. I'm not going to go into all that now for this video, but because I've probably mentioned it before. But anyway, let's get a Geiger counter out and take some readings. Right, so firstly, let's just use this little detector for a laugh to see, you know, what exactly is in there. So, it's not detecting much yet. It's obviously not that bit there. I think it probably is that rod. That's not really getting any high readings, which surprises me. Because if it was a check source, I tell you what I'll do. Let me flip this over and move the switch that moves the check source, assuming it doesn't need power to do that. You have to set it to the 5 Roentgen mark, if I remember. That's moving something there. 5 Roentgen, then put it, sorry, it's 5 Roentgen. Oh, there we go, and then put this one to R. Now the check source should be apparently exposed, but I don't actually know what that's doing. It could, of course, be the check source is actually in the ion unit somehow and it's shielded on the inside, at which stage I can't get to it, but... This is strange, because I can't seem to get a reading off of this. This would be going crazy with the amount of Roentgens this is meant to give off, but... Yeah, strange. Let me just flip this switch and see... See, I definitely think it's that check source, because when it's in that position, it goes into the bit. So, but what I want to know as well is just flick that there. If I get that back out, if I then move the switch that I had set to R, because I can hear something moving when I do that, but what is it moving? Unless the check source is just something totally different. So that's, I'm just checking which switch it is, because it's a bit awkward when I'm down at this angle trying to do it. So it's that switch, isn't it? So that'll be the check source there, that bit of plastic. So I'm assuming there's another beta window at the top end. But yeah, the check source obviously is that bit of plastic, if you see that spins out there. That is a check source. Right, so let's see if that white piece of plastic gives us a reading or whatever it is. If not, what I'll do is I'll get a screwdriver, take that bit off there. Or is that the check source on that bit of metal there? Or I think the check source might even be that bit. It's something to do with that bit of plastic anyway, and like that bit that moves with it. So let's just flick that again. So yeah, I assume when you've got one of these other switches in a different place, what ends up happening is the when you flick this one, it won't move. Ah yeah, there we go. So yeah, when you've got the switch for the radiation bit in the position, because you have to do a combo of switches as I said before, what ends up happening then with that, by the look of it, is that it just won't swing into the chamber. Anyway, let's see what this check source is. Now I'm sure this has to be something to do with the check source, because when I put the mini monitor near it, you can get readings, but it's not giving off anywhere near as much as it should for be a check source of 3.5 Roentgen per hour, even though that's what it says on the manual it should be, and I know it could have been a decayed thing or whatever. Because weirdly, the thing that looks most like a check source is that bit there, but if I expose that, this doesn't get a reading. So whether or not this somehow picks up something radioactive, and I know I'm touching it with my fingers, but or the white bit is radioactive, I really don't know. I'll wash my hands obviously off. I did get a glove, but it's too fiddly working with this with a glove. It's very strange. I literally can't figure out. That was loose. Hang on. Does this come off? Right, let's hope I don't break the Geiger counter doing this. Oh, it's not Geiger counter, is it? Right, there's the ion chamber. So there wasn't any gas in it, it's not even airtight. Oh, there we go, there's our sample. Right, after all that, I didn't even need to do that. Right, so, can you see that on the camera here? So, there's a bit of film down there. So obviously, this is the only setting where that is covered up with the plastic. And then as soon as that moves out the way, it shows you your reading. Right, let's get out of the way and check what the other Geiger counter says. I'm going to have to hope when I put this back together this all goes as it should, but to be honest, this bit is not too important for the criticality of operation. It's just a zeroing thing, and I know it says it should be 3.5 Roentgen per hour, but if I can get that to swivel out again, there we go, right. Let's put that on top and see what reading it gets. Is that alpha radiation then? That's fascinating if this can read alpha, even though it's... Because that must be an alpha source, because this isn't picking anything up, it's only the mini monitor that goes off the scale. So yeah, if you can see that. So, I know you can't probably because of how I've framed it. Hang on, let me zoom this out a bit. I'm definitely washing my hands after this, but yeah. So, off the scale, that's really hot, and that's at a fair distance. But, whatever that sample is, that's held in on a little metal plate, it seems. Ah, yeah, so that screw is what holds the check source in. And then, yeah, this is just literally a guard for it. But yeah, this, oh, yeah, I've put the plastic back, haven't I? That's why I'm not getting reading. Yeah, this is really hot for what it is. But, yeah, this can actually read alpha radiation, just not through the bottom. Because, like, obviously that's why there's papery stuff on here. So only beta goes through. But, yeah, this actually doesn't give off anything that's beta by the look of it. Let me just check with my DP66, just in case the other little Geiger counter's playing up. But I'm pretty sure that's not the case. So let's get the wand of this in here. Horrible squeaky noise. There we go. Oh, I need to tighten the probe up just a second. Right, there we go. Right, so let's put this on. To 5 milli Roentgen per hour. Put that over there. No movement on the needle, so it's alpha. That's fascinating. I've never seen a check source for a thing like this with an alpha bit of alpha radiation. So, yes, very interesting. Very, very interesting. Okay, yep. I'm a bit dumbfounded here. So yeah, that is definitely alpha, because obviously the mini monitor can pick it up with the alpha micro window, but it can't on any of the others. Fascinating, absolutely fascinating. Right, what I'm going to do, to get this back to the settings it should be, because this bit's all mechanical, let's put it onto the one where it's meant to be reading radiation, which is there, and then I'll swivel this back into the position it should be at, which I think should be there, roughly. Yeah, that's pretty much off the thing. Then I'll reassemble this. I won't bore you with this bit on camera, I just unplugged, because there was literally an electrical plug that went from one of the bits into there. So what I'll do now is reassemble it and we'll actually go through the functions. But first, I definitely need to wash my hands, because, you know, I've turned the mini monitor off now, but yeah, very interesting. I have never before seen any sort of radiation detection equipment like this, which actually can read alpha, and then has an alpha check source. But there you go. I'm assuming it's... There's another little thing there, but I'm assuming that's just something else. I'd love to know what the check source is, unless it is just a big flat piece of Americinium-241. But yeah, it's definitely not beta. But interesting. It's just weird you'd have an alpha check source for a ionisation unit that's not meant to read alpha, as far as I'm aware. But we'll test it on some Americinium when it's on. Right, so I had to spend absolutely ages putting this back together again, because Kraut space magic, of course. The mechanism in this was really complicated just to get at that thing, or I could have just taken the paper off straight away, but I thought that would have broken the ionisation chamber. Obviously it didn't. So, what it basically was, is there's kind of a ratcheting system for all the bits. And you know how this has these switches where, you know, put it in this one to do this, and then you put it in this one and you switch this switch. That sort of mechanism. You have to get it back exactly right, or the ratcheting bits won't line up with what they're meant to do. And as far as I can tell now, all the functions seem to work as they should. So, let's go over it while I'm here, and we'll quickly get the test source and check it. So, I'm going to check it with the Americinium as well in a minute, because I'm very interested if that will give a reading or not. So, this is obviously your unit, and let's go over the functions, because I'm not going to bother, you know, reading all the instructions. I know you're meant to read the instructions. I'll just zoom in a bit, not on my crotch, but on the unit itself, so you can see it a bit better. There we go. Right, so what we'll do is we'll have a look at all of the different bits of the unit on there, and then you know, the functions on it. I'll probably just put the strap on after I've... Oh no, that's how you do it. There we go on. There we go. And then this side. And now this one doesn't want... Ah, fuck it. Right, anyway. So how this works, obviously, it has a couple of test functions. So what it's saying, for do the battery check, you have this one set to B, and then you put this one on C. There we go. Oh, it's doing the battery check. Look, obviously the battery check works, and I guess that black line there is meant to be the bit it goes on. The nice thing of this is exactly like the British one I want to get, the sort of Radiac survey meter, or whatever it's called, number 2, which has the dial that swivels over with what you're meant to be reading, so you can actually read easily rather than doing the multiplication in your head. So, right, let's do the radiation test then. So what we do, we put that on R, and then obviously that should go down fairly low at the moment. It's on C. I don't know if there's an R and C combination officially on there, because there's, you know, combinations for all sorts of things. But anyway, RA is to test the alarm, but I've not got headphones in it, and I don't think it has a loudspeaker. So R and 5 Roentgen per hour is the setting you go on to 0 it. So you go to that, and this is where it exposes it to the check source. Then you have to swivel this bit, look, to 3.5 Roentgen. As much as I'm tempted to put on 3.6, let's do it on 3.5. We're just going to have to assume that that's zeroed correctly, unfortunately, because as I said, I couldn't independently test it. The whole point of taking it apart was to see, could I, you know, put everything, put my other Geiger counters on it, get a reading of what the radiation actually was coming off the test source, put the test source, put it all back together, switch it to the test source mode, and then zero it correctly. No, is the answer to that, because of how they've designed it. So well done, Germany, well done. I definitely understand now why lots of Geiger counters just have a check source on the lid or whatever, because you don't have to, you know, do all this stupid business to get at them, but, you know, Germans. So, there we go. That's set to 3.5. So, that should be the reading we want to get. So, now, if we go to 0.5, it should go off the scale. Yeah, it does. And if we go to 50 Roentgen per hour, it should get into the region. Yep, that looks about right, because it's just over where the 2 shows up there. 0 to 20. It's a weird scale, isn't it? Oh, sorry, that's 10. Well, that doesn't make any sense. I mean, I know you're only meant to calibrate it on the other setting, but, you know, if that goes up to 50 Roentgen, and that's 10, surely the needle should be right down there if it's on 3.5. Yeah, that's on 3.5 there. So, why then? Let's just turn the 0 in completely off for a minute, so we'll put that completely down to minimum. So, yeah, even when it's fully zeroed down, that goes to there. Right, what I want to see is if there is a way I can get this to go to 3.5. on this one, but also get it to sort of 3.5 on the 50 scale, which is going to be harder to do. But obviously it could be just due to the age of the check source. I don't think that's anything I've done to it. But... so that's 5 there. So I estimate 3.5 would be about there. So let's go back to 5. Yeah, I don't know if there's any way of winning on this. But anyway, they tell you to zero it on 3.5 on this one. So that is what we're going to do. It says 3.5. It says 3.5, it's 3.5. You know, that's the unit. So this is definitely a very, you know, Chernobyl-esque meter in that regard. Okay, so we've got some functions. Let's see what they do. So obviously in the measuring mode, I'm pretty sure you're meant to be on M for all of those. Yeah, so let's go to M. So now we're measuring. With R, yeah, you can't have the check source out, can you, on there? So let's go to... You see, it's definitely at the moment not being exposed to that much radiation. So has the thing fucked up again inside, and am I going to have to take this apart and re-put it back together? Right, B is off as it should be. R. So yeah, when R's on 5 point that... because there's nothing at the moment it should be picking up that is that radioactive. Let me just... I guess we could say fuck the official zeroing, couldn't we, and just do that. That's an easy solution, I don't know if it's a good one. Right, what I'll try doing now, I know this isn't how we're meant to use it at all, because, you know, or whether or not it's like the gyro in the screen's a bit off, I don't know. What we're going to do is I'm going to get a check source, and I'm going to see if I can move the needle on the, you know, 500 Roentgen per hour mode, essentially, 500 milli Roentgen, sorry. Obviously it's done on, like, points on that one. Yeah, so that's 0 to 5. I see where they've gone 0. Oh, it is 0 point, it's just like really small. Right, okay, let me get a check source and we'll see if we can get any sort of readings off this whatsoever with the strontium 90 or something, because that should move the needle in this mode. And then I'll tell you what I'll do. I'll just zero it using my strontium 90, because I know what the strontium 90's reading is. So, yep, let's do it that way. That's the easy way of doing it. Fuck the official way. Let's just do it that way. Right, so here we go. Here's the unit. We've got it on 0.5 Roentgen. Let's open the strontium 90. Let's lift this up and put it over the strontium 90, and let's see if the needle moves. Doesn't want to seem to move at the moment. Right, if that was working correctly, we definitely have a reading there. So, who knows if this works. Right, I don't want the strontium 90 firing into my crotch. Let's pop, don't keep turning around to look at me. Right, there we go. Right, so tell you what, let's go back on the zeroing mode, right? Right, we're on the zeroing mode. Let's go to 5 Roentgen per hour. Let's set it up exactly as they say it's meant to be set up. Oh look, it's nearly exactly where it should be. So that's there. Again, it could be the mechanism swiveled round inside, and if that's the case, that might just ruin this as a Geiger counter. What I want to see now is if I put this on the strontium 90, does that affect the reading at all? Yeah, it does look. Okay. So it's definitely reading radiation because the needle goes up a bit when it's on top of the strontium 90. Unless that's just it. No, that might just be it with the bloody needle that moves when you move the screen. Right. So anyway, we'll say that's 3.5 Roentgen. Oh, so it's 3.5, isn't it? It's on 2.5 there. Right, 3.5 Roentgen. There we go. Right, let's go to meter mode. So in meter mode, that is how you should get the readings. And it's already again saying there's a load of background radiation, because we're certainly not at 0.70 70 milli Roentgen an hour at the moment. Let me get the strontium 90 though and see if this will affect the reading. No. Really, I should have just tested this before I put it together. You know, before I took it apart. What I just want to do is, you won't be able to see the screen here, but what I want to do is see if it's on a flat surface like this, how that affects it. And again, you get a completely different reading if it's on the flat. Right, I'm just going to play about with this for a bit and see if I can get any sense out of it. If not, you know, don't buy an old German Geiger counter ISO chamber, because if you have to do any maintenance on it, it probably won't work again. Alright, I think I've got it working. I don't think it was a problem with the internal mechanism. I went through all these in order, and it seems to have an incredibly complicated setup system. So basically, what the issue seems to be, also, firstly, if it's round that way, the zeroing is different than if it's sitting up top. So I guess just leave it one way and set it and keep it like that. So basically, you do all the circuit checks, check they were okay, they were. Then what I'm guessing you have to do with my very broken German is you have to make sure on that one that it's at 0 when you put it on M and C. So then I set that to 0. Then the alarm I didn't bother checking because you have to plug the things in for that. Right, then on the 5 Roentgen per hour, I guess where it's saying 2 bis 3.5 Roentgen per hour, it's saying it has to be between 2 and 3.5 Roentgen per hour. Like, it doesn't actually have to be exactly on 3.5. So let's go to 5 Roentgen per hour, and it's on 2.5. So 2.5 is pretty good between 2 and 3.5 in terms of an average. And then it means if we go to the 50 Roentgen an hour of the check source, it actually goes to, you know, pretty much the same number. It's not like, you know, just a completely different number than it should be. So I guess what you have to do is adjust the voltage to the battery or some shit like that, and then you can use this as a Geiger counter. Right, or an ionisation detector, whatever, same sort of thing. Radiation detector. Right, let's go to the meter mode, and let's go down to 0.5, and let's see. Right, good. The needle at the moment is barely showing any radiation, as it should be. Right, now let's see if it will actually take a reading. So, what we're going to do now is put this under here, put the on top. I think the needles move slightly. Yeah, it's annoying because obviously tilting it will move the needle anyway. I don't know if there's like some sort of stabiliser in there that's broken, but this isn't very good if you've got an infantry handheld radiation detector, is it? And when they go to look at it, the needle moves because it's, you know, it needs to be literally shut. Tell you what, let's put it back in its bag, shall we? Before we make any further assessments, let's put it in its bag. So it's completely as it's meant to be, because German engineering. You know, something that they can make incredibly good things when they want to, but they also make things needlessly complicated, which means why they break. This is why I prefer sort of the Slavic Russian approach, where it's meant to be idiot-proof. So, for example, I can use this and not break it. Right, I'm assuming this isn't a check source, I'm assuming this is a dog tag, but let's just see if this does anything if I stick it underneath. Oh, it doesn't reach underneath. Right, this can go back in its bit in the lid then. I don't have no use for you. It probably says, this is issued to this person. Right, so we're on meter at 0.5 Roentgen per hour, and currently it's reading about 0, as it should. So we've got the gamma shield there. Let's open the gamma shield up so it can read beta as well, because I don't, thankfully, have any sources of gamma radiation that are that high. So then what we'll do is, let's do it like we should properly do it, eh? And let's see if it suddenly works, because it's German. So, here, I've got my thing. I assume you fold it like that when you're using it. And you've got your radiation check source, so let's see. Again, this is really awkward to try and do it without needle going everywhere. Yeah, it's moving the needle, although bear in mind it should be moving to about there. Hans, I think we will be tossed in an actual nuclear war, because this does not tell us how radioactive things are. Alright, just for shits and giggles, I'm going to flick through all these and check these go to where I think they should. Right. It's now saying on MC contour check. That's, I've gone back to the control stuff, haven't I? And that's where it's meant to be exactly 0. Alright, shall we go through the setup again? Sorry, this is probably a load of it out of frame. This is very frustrating. Right, let's go through all the steps again and we'll evaluate if it still works. I don't think I've done anything in this that would have actually, you know, stopped the functions working correctly. So, we are on else, that's off. Okay, the off function works, we've got that. Right, so now we go to B and C. So B, C, and it says, basically make sure it's in the check mark area, which it is, because I'm assuming it's that band there, like the regular battery checks you have on these sort of things. Then we go to M and C, and it has to read 0. So, M, that's 0. Well, that's a bit over 0, isn't it? Under 0. Let's put it on 0 exactly. Hang on. Ooh, fiddly, fiddly, fiddly. Right, there we go. Right, that's on 0 exactly. Now I want to just go back to B and C and check it's still within that area. Good, it is. Okay, so those 2 steps we've managed. That's something, isn't it? So next we have to do RA. I'm not going to bother testing the alarm because I've not got headphones plugged into it in a minute, and that's an extra feature. Right, so now we need to go to Roentgen, and we need to go to 5 and check it is in between 2 and 3.5. Yes, it is. Okay, so according to all these checks, we're ready to go. So of course, now what we need to do is go to the M for measuring, go to 0.5 and see if we can get any readings. I'm not too confident myself, in all honesty. Right. Nothing. The strontium 90, which would definitely normally move something like that, is not moving it. Where it looks like it's moving there, that's just because it's tilted. Because see, this is the issue with it. You tilt it, the needle moves based on you tilting it as well. So this should actually be called a gyro detector, not a radiation detector. How am I moving it? That makes the needle move. Yeah. This might have been a good bit of kit if it was in working condition. It's clearly not. Maybe I've played a part in making it not work properly. It's still quite a cool old thing, but it shows you why you don't over-engineer stuff like this. Because when you over-engineer things, people's lives may depend on, they die. So there you go. I'll just quickly check it with the Americinium check source. I don't think we're going to get anything from it, but you know, I'm just going to hold that coin directly under there. No reading. Because bear in mind, this is on the lowest setting, and because that's 500 milli Roentgen there, it should be about now, because, as I said, I've used that with other Geiger counters I'd actually trust. So anyway, what we're going to do is put the Americinium bit from the mini monitor. This isn't very practical, but hang on. I'm going to put that there. Will it get a reading off of that? It's weird how it can apparently detect alpha but not detect alpha. I suppose it has got that paper bit, hasn't it, on there? Again, the main issue is this bit, how it, you know, like rotates with how you move it. I might take the back off again after this video and just see if there's anything I can do with that. But anyway, just to prove to you, obviously, this isn't working. Let's put it back to off. So yeah, just as a bit of proof, here's a proper, you know, British-made one. Very simple. You can do a battery check. Oh, there we go, that works. And you can turn it on. Right. Not a German piece of kit, but it works. So here's the difference. Yep, so there we go. I don't know what to say about that thing. It could potentially be very good if it was in working condition, but I think it's horribly over-engineered. And because it's meant to be a military piece of kit, it's probably going to be broken. That's probably why they're not in service. So there you go.